Okay, so on these problems, they're just some interesting base number problems, and we want to use what we learned last week about base numbers to solve them. And this first one, it says, how many zeros does 40 factorial have at the end when expressed in base 3? So 40 factorial would be a base 10 number. And we know how to find out how many zeros would be at the end of 40 factorial. It's essentially how many fives are there, because if you're thinking about a normal base 10, when you start multiplying this out, you have 1 times 2 times 3 times 4. There are no zeros at the end of that. That's actually 24. But when you introduce a 5, 5 times an even number always ends in 0. And then as you keep going, every time you get another 5, which there's a 5 embedded in this 10, 5 times 2, you get another 0 at the end. And so we could figure out that if we were talking base 10. But base 3 is a little bit different in that what we're really looking for in base 3 is how many 3's are there in 40 factorial instead of how many 5's are there in 40 factorial. Because if you think about it, so for instance, like a number like 24, there are 1 3, it's a multiple of 3. And so since it's a multiple of 3, it's not going to have a, remember your, to do base 3, it would look like this. How many 3 squareds are there? How many 3 to the first? How many 3 to the 0? Well, since it's a multiple of 3, you can do this by saying there are 2 9's and 2 3's. 9 plus 9 plus 3 plus 3 is 24. And then there are 0, 3 to the zeros. When you include 27, now 27, it actually has something on its own, right? And so if you got to 27, that would actually have 3 zeros at the end of it, because you'd have a 1 here, 127, then a bunch of zeros after that. So what we're looking for is how many 3's go into 40 factorial, because that's how many zeros you're going to have at the end. If you got 1 3 at the end, then you got a 0 there. If you got 2 3's, then you got a multiple of 9. Your number's a multiple of 9, so everything's going to be able to go here. If you got 3 3's, it's a multiple of 27. So how many 3 goes in 40 factorial? Well, the way we do this, we divide by 3. How many 3's go into 40 factorial? Well, that's going to be 1. There are 13 3's that go into 40 factorial. How many 3's go into 13? Well, there are 4 that go into 13. How many 3's go into 4? There's 1 that goes into 4. So there are 18 3's that appear in 40 factorial. That means there are 18 zeros at the end. So you just go through and divide whatever your base is, and it's actually got to be a factor of the base. And then that's how many multiples of 3 are in 40 factorial, and so that's how many zeros. So in this case, if we're talking base 8, well, the difference between base 3 and base 8 is base 8 is the same as 2 cubed. So we need to know how many 2's there are, not how many 8's are there. So how many 2's are there in 40 factorial? We'll do the same process we did there. How many 2's are there in 40? There are 20. How many 2's are there in 20? There are 10. How many 2's are in 10? There are 5. How many 2's are in 5? There are 2. How many 2's are in 2? There are 1. So how many 2's are there in 40 factorial? It would be 38. There are 38 2's in 40 factorial. So if we were saying how many zeros would be in the base 2 representation of 40 factorial, the answer would be 38. But we're looking for the base 8. So the base 8, divide this by 3 to find out how many 2 to the thirds are in here, and you're going to get 12. And so the answer to this would be 12 zeros at the end. So there are 12 zeros at the end of 40 factorial when it's expressed as base 8. Another interesting example of a problem is how many base 6 numbers less than 1,000 base 6 contain a 5. This is interesting because you could go through and try to count it. We've done problems like this when how many 2-digit numbers have a 3 in them, right? If you're talking about base 10. So if you could go through and start counting, start listing them. So you could start with your first number less than this would be 1 base 6, and then 2 base 6. All right, and so the first one that would contain it would be 5 base 6. Okay, and so then if that's the only one that would have 1 digit. The number of 2 digits would be, right, 15, 25, 35, 45, 55, and 65. And then also 51, 52, actually 50 also. And you could go through and you could continue listing like this. We've already done 55. Actually, my bad, 65 and 56 wouldn't be included in there. And you could go through and continue listing like that until you got the answer. But the better way to do it is to think, okay, in reality, I've only got three numbers that matter because this is going to be a 3-digit number. And for each of these, there are 6 different digits that can go into these, 0, 1 through 5. And so there are 216 3-digit or less, 1-digit, 2-digit, or 3-digit numbers in base 6 that are less than 1000. So there's 216 numbers. You could have 6 possibilities for the first digit, 6 for the second, 6 for the third. This counts 1 and 2 digits because these right here could be 0. And if those are 0, that gives you 1 digits and 2-digit numbers. So that helps us, but we want to know how many contain a 5. So the best way to do that is to first calculate how many don't contain a 5. If they don't contain a 5, that means 5 times 5 times 5. Because there are 5 numbers here that are not a 5, 5 numbers that are not a 5, 5 numbers that are not a 5, right? 0, 1, 2, 3, 4 for each one of those. So there are 125 that don't contain a 5. So if there are 216 total and 125 that don't contain it, subtract the 2, and you end up with 91 numbers, and that is the number of numbers that are less than 1000 base 6 that are in base 6 and don't contain a 5. Again, it's called complementary counting. How many total are there? How many don't have what you want? So how many contain a 5? The last problem we're going to look at is to do some addition and different bases. One way to do these problems is to convert both to base 10 and then convert back to, do the addition and convert back to base 6. However, base addition is just like addition we know how to do, except that your carrying now happens with multiples of whatever the base is. So for instance, on this first one, if we put it like we first learned to add, 331 plus 224. 1 plus 4 is 5. And so that means we just have 5 6 to the zeros. And it also means we have 5 6 to the ones and 5 6 squareds. We didn't have any extras, so we don't need to do any carrying. So the answer to this problem is just 5 5 5 base 6. However, you can get into situations just like in base 10 where you get more than what you should have. If I add 4 plus 2, or 4 plus 4, that gives me 8. Well, 8 is bigger than 6. Okay? Right? And so, how much bigger is it? It's 2 bigger. We carry it. That means we had 8, so that means we have 1 extra 6, so we carry it to the 6's column. Or 1 extra 6, we carry it to the 6 columns. When we add these up, there are 4 6's. We don't have any extra 36's. And so we can add these two. 5 plus 5 is 10. That means that there's 136, or 216, 36 times 6, and then 4 left over. So there are 4 36's here, and then 1 216. So again, if you're doing it in a different base, it's all you just use that base number to know when your carrying happens. So this answer is 524 base 6 plus 514 base 6 is the same as 1442 base 6.